Excellent. Okay, well, welcome everybody. We have almost a full room. Excellent. My name is Luis Vargas. I am a program manager with the SQL Server High Availability team. So for the last 2 years, I have been working in AlwaysOn. Next set of high availability technologies in SQL Server 2012. So it has been a big effort, around 60 people working for 2 years. I'm super glad now that we have shipped, so we can sleep a little bit. That's excellent. But I'm really excited that customers now can start using AlwaysOn for high availability of their mission-critical Tier 1 applications. It has been a great experience over the past 3 to 4 months interacting with customers who are starting to implement AlwaysOn to support really critical applications where sometimes before only Oracle was the solution. So we're trying to get into that segment. We have made a lot of investments into high availability for this release. I'm really excited about them. Today, I'll be talking briefly about AlwaysOn in general. We have had already a bunch of talks, I think last TechEd as well as other conferences about AlwaysOn. So I'll touch for the first 5 to 10 minutes about AlwaysOn in general, just setting the context, and then I'll jump straight into active secondaries. And my hope is that by the end of this session, you have a good context into what AlwaysOn is, what it provides you, and then a very good understanding of what active secondaries are and how you can use them to make the best use of the hardware for your high availability solution, right? If you have any questions, anything isn't clear, I'm going too fast, please just raise your hand, stop me, and I'll try to answer your questions. Any questions about AlwaysOn or active secondaries in particular? If you want to talk about the football game tonight, we can talk about it as well. So let's start. So my objective for this session is I want you to understand how active secondaries allows you to use your high availability hardware for something else than just waiting for a failover from the primary to happen. I want you to understand how you can run read workloads into those into that hardware, and how you can run backups into that hardware as well. I want you to understand the capabilities that we have in this release, as well as the limitations and some considerations. I'm actually currently going through the planning for the next version, for the next release. So we can discuss a little bit into what are the things that we have seen with customers and what are we planning to do for the next release. So in terms of the agenda, we'll talk quickly about AlwaysOn, and then we move straight into active secondaries. And we talk about how do we move read workloads from the primary into the secondaries, and how do we move backups from the primary into the secondaries. So setting the context quickly, I have seen some confusion about exactly what AlwaysOn is. Some people believe that AlwaysOn is a new technology. It's not exactly that. AlwaysOn is the marketing term that we are using for the high availability solutions in SQL Server 2012. Right? We currently have 2 solutions as part of AlwaysOn. One solution is failover cluster instances. So this is a solution that we had in the past for 3 releases already, where you can cluster a SQL Server using Windows Cluster, right? And then you have different instances of SQL Server that use shared storage. So you can have a SAN, for example, or now you can have an SMB share. And they're sharing basically the data in a single place, right? And we're providing high availability for those SQL servers. This solution basically provides ability for the full instance. Like if the instance fails, we just restart the instance in a different node. And this failover can take minutes, right? Because you need to restart the instance, and all the databases in that instance need to go through the recovery stage. So it can go between 2 to 5 minutes. And there have been some enhancements into SQL Server 2012 to make this faster, but it still is a couple of minutes. And the next thing is all the clustering nodes in this case are passive in the sense that you cannot use them to go and read secondaries while you have another primary in the system. Now, the new solution that we have in SQL Server 2012 is called availability groups. These availability groups, you can imagine, is like database mirroring with lots of asteroids. Like it has been enhanced in multiple ways So the first thing is we have a multi-database failover. This means that in an availability group, you can have multiple databases that, in the case of a failure, are going to fail over together. Right? Remember, with mirroring, you only have one. So if your application depended on multiple databases, you needed to establish a mirroring session for each of those databases. So not very good. We have, what else? Direct attached storage. So some people get a little bit confused about this. This means you don't need to have a SAN for availability groups. Each of the replicas in the availability group only requires its own local disk, right? Failover can take seconds. So basically this means the secondaries SQL Server already have a copy of those databases that are online and ready to take over in case of a failover. So we have seen customers with 15 to 20 seconds. We actually have seen customers with less than 10 seconds failovers. All of this really depends on the hardware that you have, the latency in the network, and the amount of transactions that you're running on the primary. We have this notion of multiple secondaries. So you can have up to 4 secondaries. So you can have your primary and 4 secondaries distributed in the environment. And all of these secondaries can be active. So in terms of what we're going to talk about in this session, we're going to talk about availability groups, right? And we're going to talk about how to use active secondaries in availability groups. Okay? Again, setting the context, this is how a traditional availability group topology looks like. So you can see on the right side, we have, so imagine that's the states, and then on the right side, we have the primary. In this case, is AlwaysOn server 2, right? And then that primary has a local secondary called AlwaysOn server 3 for high availability, right? So if my primary fails, I want to automatically fail over quickly to that secondary in the same data center. Now, you may have, if you want to, another secondary living in a different data center, but close to your primary data center. For example, there may be a part of the organization that is, a few kilometers from your data center, and you may want to have a secondary copy in that data center so that applications can locally run against that, right, without having the latency to the primary. In that case, that will be server 4. And as I will show you, you will be able to run, for example, backups in that secondary, right? And now, for disaster recovery purposes, right, imagine that that part of the state, for some reason, becomes unavailable. You can have another secondary on the other side of the country, for example, AlwaysOn server 5, that allows you to support disaster recovery, right? So in the case that this part fails, you can always fail over to that part. In the meantime, while that doesn't happen, you can still use that secondary for something else. In this case, for example, you can use it for reporting applications, right? So you can run those reporting applications against that secondary. Questions? Is that clear? Oops, sorry. Something that I mentioned is those arrows, the one in the left means synchronous data movement. So I don't know if people are familiar with this. We have the concept of synchronous and asynchronous replicas. Synchronous basically means the primary will only commit a transaction if the synchronous secondaries have committed the transaction as well. And that is to ensure that there isn't data loss in the system, right? And that generally is used either within the same data center or in data centers that are very close to your primary because there is little latency, and then you won't impact the latency of your primary. Or you can have asynchronous replicas, right? And this is when they are very far, like in the case of the disaster recovery one. You don't want to wait in the primary until the transactions are acknowledged from the secondary because that adds latency to your transactions, right? And then your workloads are going to suffer for that. So you want to use asynchronous replicas in that case. The only consideration there is if you use an asynchronous secondary, there may be transactions which haven't been committed on the secondary. And because of that, there may be potential data loss, right? How much data loss? That will depend on the latency on the network between the primary and the secondary. Okay, so, we are in interesting times, a lot of economic crises. We need to make sure that we are cost effective, that whatever hardware we use for whatever purpose, in this case high availability, is used efficiently, right? So we don't want secondaries that are just waiting for a failover to happen and not do anything else. We know, for example, from database mirroring, after talking to customers, that the mirror uses around 5% CPU and 25% I/O. So if you think about it, you have 95% CPU that you're not using, and you have 75% I/O that you're not using in those servers, right? And in general, because that mirror needs to be able to take over the primary, right, to run the same workloads, often it has to run the same expensive hardware, right? So that's a machine that is going to be expensive, and you're not using anything for it, right? So we introduced this concept called active secondaries with availability groups. And what this allows you is to use those secondaries to either read workloads, right, or to run backups. So let's talk about how do we run workloads on the secondaries. Okay. So how do we do it before SQL Server 2012? Well, you have two options. One of the options, or you have three options, actually. One of the options is you run it on the primary, right? So you run all your workloads on the primary, and then those read workloads may be containing resources with the general OLTP workloads, right? So you have a lot of reads, and generally reporting applications have expensive queries, and those are going to be competing in terms of CPU and I/O with your general inserts, updates, and deletes. The other option is with database mirroring, you could have a mirror, and then you will create snapshots from time to time, right, in that mirror, and then you will run those queries in the snapshots. There are a few problems with that. One of the problems is the snapshot gets stale. That means you take it today, tomorrow it hasn't been updated. You need to take another one, right? So you either do that frequently, or you're going to run queries on an old copy of the data. The other thing is there is additional management. Now you need to create some jobs to start creating these snapshots. There's additional things that you need to take care of. The other thing is, if for some reason the mirror becomes unavailable, right, those reporting applications that were running from the snapshot in the mirror won't be able to continue running. The other option that people are using very frequently is transactional replication, right? So the idea here is you have a bunch of subscribers, and they subscribe to the objects in the database, and then those objects get replicated there, and the queries run against the subscribers. There are some good things about it. You can have a very large number of subscribers. Like we have customers who have hundreds of subscribers, right, distributed across the world, and it works well. Other good thing is you can actually create indexes specific to your read workloads on those subscribers, right, which can be different from the primary workloads, from primary indexes. Now, there are some bad things about replication. One of the bad things is, well, the first obvious thing is there is an additional solution now that you need to configure and maintain, right? So now you need to have expertise on transactional replication for reading workloads. And also, if you want high availability, you need to have expertise in database mirroring or log chipping or failover cluster instances. So you need all this additional expertise. The other thing is transactional replication works with agent jobs. From time to time, they are pushing changes into the other side. It's logical replication. The problem is these jobs are running from time to time, but it's not a continuous stream of changes. And even if you configure your jobs to run super, super fast, there's still going to be a few latency issues. One of them is, given that it's logical replication, this means that we actually redo all the DML operations on the secondary. That is not as effective as just redoing the log, right? There is additional work that needs to happen on the subscribers. The other thing is that we actually do not compress the data that we move from the publisher to the subscribers. So because of this, the latency when you read these workloads in the subscribers may take additional time. So we actually have some customers who were running transactional replication before, started playing with availability groups, and they found out that the solution was around 6 to 7 times faster, which is really interesting. And I'll talk about why this is interesting. Anyway, the other bad problem about transactional replication is that, again, if the subscriber fails for some reason, you need to reconnect those applications to either a different subscriber or to the publisher, right? It's an additional process. Is that clear? Any questions about this? Okay, so how does it work now with availability groups in SQL Server 2012? Well, the way it works now is the secondaries are readable. So what you have in the picture is you have a primary. The primary has two databases. You have the secondary. We have continuous log synchronization. This means as transactions are executed on the primary, we send the log, and we actually send a compressed version of the log to the secondaries, and then we redo that log on the secondaries. It's actually physical replication. That means we don't redo the DML statements. We just redo the physical log. And then while this is happening, you can have reporting applications connected to the secondary and running the workloads there. The transactions that are executed on the primary are eventually available in the secondary. And when I say eventually, this generally is a few seconds. So we have seen customers between 1 to 5 seconds. How long will depend on the latency of that log synchronization process, right? And that log synchronization process will depend on the latency of your network and the I/O available in the secondary machine, right? So as I said, within the same data center, we generally see these transactions observed in the secondary after less than a few milliseconds, very, very, very fast. In the case of a different data center, it's generally less than 5 seconds. Another thing that is new is that now you can have multiple secondaries. As I mentioned, we have up to 4 secondaries. And you can be reading from all of them, right? So you can imagine how you can start affinitizing different applications to different secondaries and have a distribution of the load across all of them. And these secondaries can be synchronous or asynchronous, right? In any of them, you can read. Something really, really exciting here is that the read workloads can be automatically routed to a readable secondary, right? And actually, if that readable secondary becomes unavailable, for example, because SQL Server dies, we will automatically route you to the next readable secondary that is available in the system. Right? So you can forget about having to change connection strings and all that stuff, because we'll handle all that for you. So for example, in this case, imagine that you were running these reports on the secondary, and you do a manual failover from the primary. Right? So for example, you may want to upgrade the operating system on the primary, so you say manual failover into the secondary. So manual failover happens, that guy becomes the primary, the primary becomes eventually the secondary, and eventually log synchronization will happen on the other way, right? And we'll automatically route those reporting applications to the new secondary. Okay? Yes? Very good question. The question is, does the application need to know the SQL Server names of all of these guys? No. People will kill us if we have to do that. No, I'll show you in the demo. Actually, we have something called an availability group listener. That listener is just a DNS name, and that DNS name is always mapped to, by default, the primary. So it always connects to the primary by default, irrespective of where the primary lives. But by adding a connection string keyword, which is called, I'll show you that, application intent, you can say, my application is a read application, and then we'll always route you to a readable secondary. But you don't have to know the names of the SQL servers. Okay? And we'll see that in the demo in a couple of minutes. How do you configure these secondaries as readable? So we have this setting called allow connections. The first weird thing that you'll see is that it's not only yes and no, right? It's more than that. So the question is, why is not only yes and no? So the reason is to be able to handle legacy applications, applications that are not able to change the connection string, right? So if you say no allow connections, that means I don't want to allow any connections to this secondary, right? So for example, you may want to protect the secondary. You don't want to run any connections there. You just want it to be as available for failover as soon as possible without impacting the secondary with any workload. So you say no connections. Or you can say I want every connection, all connections, right? Now, we have another setting called read-only connection. So the difference here is with all connections, we will accept every connection, right? Connections for applications that for applications that the connection string doesn't change, we'll still accept those, right? So if you have some third-party applications and you don't have access to the source code, you can change the connection string, for example. We'll still allow you to connect using all. Now, if you have new applications and you have access to the connection string and you can change that, we can give you additional capabilities, and I'll talk about those capabilities. Now, what I have, one of those capabilities is this read-only setting. If you specify read-only for a secondary, that means that I will only accept connections that in the connection string specify read-only. And the reason why we do this is that if you specify read-only, for example, if you specify read-write, for example, in the connection string, or you don't specify anything, I want to protect my secondary, and I want to make sure that those applications that are read-write, that will try some inserts, updates, or deletes, can't connect to my readable secondary because I know they're going to fail. Right? The secondary is only for reads. So I want to protect that, and to avoid those applications from connecting to the secondary, I can specify read-only. Is that clear? I think I went through a lot of things, but that's the explanation. Yes?
What if the failover of secondary becomes primary in case it is?
So the question is, what if the secondary fails over to the primary? So the setting is only for when that SQL server is a secondary. Only when it's a secondary. It doesn't apply for primary. We have another setting for primary, and I'll show you that. So as usual with SQL Server, you can do this operation either using T-SQL, and that's the T-SQL. You say alter availability group, and you specify an availability group. You modify one replica, one of any of the replicas, and you say with secondary role. So this is the keyword, right? We're saying when that replica is a secondary, I only want to allow those connections, right? And then you can say no, all, or read only. Right? As usual, you can also do this through Management Studio, the user interface, and it's a lot cheaper, right? A lot easier. But just giving you the full context here. Okay. Now, that was for SQL Server. What happens with the applications, right? So for the applications, there are two options. Either if the application cannot modify the connection string, in that case, you can still connect to these secondaries, but you have to specify allow connections all in SQL Server, right? But if you have access to the connection string, you can specify that new keyword called application intent, and that specifies what is the intent of the application. Is this application a read-write application? Is going to execute inserts, updates, or deletes? Or is it just a read application that will only run select statements, right? So if you specify this, we will allow you, as I said before, to stop connections. For example, stopping read-write connections into the readable secondary, or stopping read connections into the primary, because you say, I don't want to run read connections on the primary. I want to use the secondaries for that. The other thing that you can do is automatically route those read connections to an available readable secondary, right? And we will provide you high availability for your read workloads, so that if the readable secondary becomes unavailable, we'll route those applications to another readable secondary. Okay? Yes? Yeah?
So I said allow connections on my secondary to all.
Yes?
What happens if the application connects, does some reads, and then suddenly it throws updates?
It will fail.
It will fail.
Yes, so applications that try to write into the readable secondary are going to fail, similar to trying to write to a read-only database today. Okay?
So how do I make sure that the application does go to the primary and another application goes to the secondary?
So in that case, that's an interesting question. So if you have an application today that you can't access the connection string, and you need to be able to fail over that application, unfortunately today, that is a manual process, right? So if the readable secondary fails, for example, and that application at some point needs to execute some updates, then you need to move that into the primary, right? So basically, at this point, we don't have the intelligence yet to route specific SQL statements to these secondaries. You have to tell us whether the connection is only going to run read workloads or read-write workloads. And based on that, we'll route you to one of the secondaries, right? But hopefully in the future for next releases, we'll be able to actually detect specific statements and be able to start routing this in smarter ways. Okay, so that was for configuring SQL Server for accepting readable connections when it's a secondary, and then for the connections to specify what is the type of workload that they're running. Now, if you want this automatic routing, right, of the connections, in case that one of the readable secondaries becomes unavailable, routed to another one, right, that is a setting that you need to specify. And that setting is specified through something called the routing. There are a couple of settings. Sorry, I'll show you this through the demo, and hopefully it will be clear. There are two settings that you need to specify. One of the settings is each of these secondaries needs to listen to read-only connections somewhere, right? So you need to create an endpoint to listen for those connections. So this is what you have in the screen. So for each of these secondaries, what you need to create is something called the read-only routing URL, and this is basically an endpoint where that secondary is going to listen for read connections. Imagine this is similar to the database mirroring endpoints that we have today, or the service broker endpoints. It's just a way where applications that are read-only can connect to that secondary. And that endpoint has a protocol similar to database mirroring. It has TCP, and then you have to specify the address of that secondary. The address can be either just the SQL Server name, so you can have SQL Server blah 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 blah, or it can be an IP address, right? It's something that allows you to identify the secondary, and then it has a port. That is the port where read connections are going to be routed to the secondary. Is that clear? That's one setting that you need to configure in SQL to allow these connections to be in a specific port. Now, to be able to route from one secondary to another, in the case that the first one becomes unavailable, right, that automatic routing requires of specifying something called a routing list. The routing list tells the primary, these are the secondaries that are available for read connections, right? So you specify this list of connections, this list of secondaries, and if one of the secondaries becomes unavailable, then the primary will automatically route read connections to the next one in the list. So a very common question that I get is, do we support automatic load balancing today? So we don't support it today yet. We have many customers that are actually doing it themselves. They have basically an application that just looks into a DMB. We have all the replicas in the system in a DMB, and then they say, this one connects here, this one connects here, this one connects here. So we don't support it yet, but you can implement it if you want, right? And it doesn't take that much. It takes a few hours, and you have basically a routing application in the middle. So if you want to specify this read-only routing in SQL, with T-SQL, this is how you do it. You say, modify this replica, and you say, when this replica has the primary role, so when this replica is a primary, this is the set of secondaries that it can use to route for read connections, right? And the reason why we have this command for different primaries is because you can have failovers in the system, so different replicas can take the role of primaries, and each of these primaries needs to be able to route to the secondaries in the system, right? This is why each of them needs to have this read-only routing list. Is that clear? Are there any questions with this? Okay. So let's jump into the demo. Hopefully the demo will clarify everything, and if there are any questions, we can look at them. So let's see. Yes, worked. Okay. Okay. So what we have here is SQL Server 2012. I have an availability group that I have already created. Right? The availability group is called AdventureWorks AG. It's just the name. That availability group has 4 replicas. It has one primary, Server 2, that I'm currently connected to, and it has 3 secondaries, Server 3, Server 4, and Server 5. You can see Server 3 and Server 4 are configured for synchronous commit, right? And Server 5 is asynchronous. And then you can see that Server 3 is automatic failover. So this configuration is mapping the picture that I showed you in the beginning, right? Where Server 3 is for high availability of Server 2, quick automatic failovers in the same data center. Server 4 is a secondary that is close to the data center, and you can use it for read, for example, in a different office of the company. And server 5 is for disaster recovery purposes, right? It's an asynchronous replica for disaster recovery. Now, the availability group has 2 databases, right? And it has a listener. And remember, the listener is the name that my applications will use in the connection string to connect. Okay, so actually, let's go and show. So what I have here is 2 applications. This one is an old TP application, so it generates inserts, updates, deletes, right? Hundreds of those applications, hundreds of those statements per second. And this one is a reporting application, so this one is just selecting hundreds of records per second, right? So let's look at the connection string. So the connection string here for the old TP application has the SQL native client provider for SQL Server. It specifies the listener. This is the availability group listener, right? It specifies the database to connect in that in SQL Server. So the listener will always connect to the primary, and once you connect to the primary, this is the database that I'll connect to. And this is just a timeout, right? If I can connect, how long do I wait before trying to connect again? Okay, so I can go and run that application. So when I run this, you see that this starts inserting records, hundreds of them. So you can see that in this table I have more than 1 million records, and there are this number of inserts per second, right? So that's into the primary. Now, how do I use the secondary? Well, you could just specify server 3 here, which is the secondary. But if I try this is going to fail. Any ideas why this is going to fail? Because I haven't configured it yet as readable, right? So if I try this, it says, I can't connect because this is not a readable secondary, blah, blah. So what I need to do is go into the availability group, click in properties, and then you have all the replicas here, right? Primary plus secondaries. And then I can specify whether I want this to accept every connection or only read connections that specify read intent, right? So let me say I want to accept read connections in all of them. And then I say, OK. Actually, this is the other setting that I mentioned before. In the primary, you also have this setting where you can say allow every connection or allow only connections that specify read-write, right? And then you can block, for example, read connections from the primary. So if I say OK here, it's going to make all these secondaries readable, OK? And now, let's see, hopefully this will work well. OK, so if I specify, you can specify server 3, for example, and this will take a couple of seconds. Just the first time that after you configure this as a readable secondary, it takes a little bit more. The rest is faster. And you can see that I have automatically connected to server 3, right? Because I specify server 3 in the connection string. Now, the problem here is if for some reason I fail over, right, I will still be connected to server 3, and I'll try to run that read warlord in server 3. But what I want is to run that warlord in a readable secondary, right? So what you can do is then, instead of specifying the name of the server, you can actually specify the listener. And I think I have it somewhere, so let me see if I can find it. So I'm going to copy this, and then I'll show you the connection string. OK, so the only difference here is, one, I am using the listener of the availability group instead of the physical server name. And two, I'm specifying this application intent equals read only to tell SQL Server that I'm interested in running in a readable secondary. OK? So if I change this, this will automatically connect me to server 3, because that's the, actually I didn't show you that. Let me show you how you specify this list of readables. readable secondaries so that you are mapped in that order. So this is how it works. So the first thing that you have to do is go and create those read-only URLs in each of the secondaries so that applications can connect into those URLs. So I'm going to do this for each of my secondaries, right? So I specify for server 3, connect into this name and port, server 4, and then server 5. So this is just to open the port to listen for read connections, right? And now the next thing that I have to do is to create that list on the primary of these readable secondaries so that my connections are routed in that order, right? So I'm going to say on the primary, server 2, this is the list. I want to route first to server 3, then server 4, and then server 5. I want server 3 just because it is a synchronous replica, right? It is closer to my primary. So it's very likely that that is going to be synchronized to the primary, and I'll be able to read the same transactions as in the primary because there is very little latency, right? So that's why I have server 3 first. So I go and run this. And now, if I connect my read application, it's going to connect to server 3, which is the first readable secondary available in the read-only routing list. Okay, so you can see that this is retrieving records from there. Now, as I mentioned before, we provide you high availability for those read workloads. So let me do something. I'm going to shut down server 3. So server 3 is the readable secondary. I'm going to stop SQL Server, right? Bring down the service to show you how that application will automatically reconnect to another readable secondary. So you can see that the connection has failed, right? The connection failed here. Now the application has retry logic. It will try to reconnect using the same availability group listener. And then after a few attempts, it will be automatically routed to the next readable secondary that is available, right? And you'll be able to use that one. So it seems it takes a little bit. Okay, so you can see here that it has been routed to server 4, which is the next one in the list. So we are providing high availability for your read workloads as well, right? That's simple, right? It's very, very easy, and you get high availability for them as well. Okay, so let's go back to the presentation. And actually, let me bring back this guy up, because I'm going to need it for my next demo. I'm going to restart it. Stop. Okay. Okay, so let's go back to stop. Okay. Okay. So any questions about the demo? This thing doesn't like me. Yes? Oops, sorry. That's a good question. So the question is, how do you decide which secondary is going to take over in the case that the primary fails? It's very easy. You can only have one secondary. So you actually specify it in the availability group properties. So you go here, and then you say properties. And you see that you have failover mode here. So you can specify only one secondary as automatic failover, and that's the secondary that you will automatically failover to. Is that clear? Okay. Any other questions? Oh, okay. So, yes. 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 So the question is, for the listener, do we use Windows cluster? Yes, the answer is yes. So the way it works is when you create the availability group listener in SQL Server, we register that listener as an IP resource in the cluster. And now what cluster is going to do is it will register that IP resource in the DNS as well. So we have basically some magic. When failover happens, we update the DNS, and we make sure that IP resource is pointed to the primary. in the DNS server.
So in the case of two data centers, as this
Ah.
5 plus there,
Yeah.
so I have a multi-site because
Yeah. Yes. So the question is, what happens if I have two different data centers? How does it work? So the way it works is when you create the listener, you need to specify an IP for each of the subnets that you have in the system, right? So you have two data centers, you're going to have two different subnets, and you have to specify an IP in each of those subnets. So that's actually a very good question. When applications try to connect across data centers and across subnets, by default what happens is the client connectivity driver will try to connect iteratively. So it tries to connect in one randomly, and then tries the next one. And that can add to connection time, right? So because it may not be able to connect quickly to the first one. So there is a keyword called multi-subnet failover. So if you specify multi-subnet failover in your connection string, the applications will automatically try in parallel to connect to the listener in both data centers. Only on one of them, the primary will reply, and that's where the one you connect, but it reduces the connection time. Okay? So you can read more about it by going into books online and looking for availability group listener. Okay, I don't know how I'm doing in time. This is basically going into more detail of how this works underlying. So I'll probably go a little bit faster here. This is, I don't want to spend too much time here because we still have the backup aspect. So this is how does the log synchronization between the primary and the secondary works. The way it works is while transactions are running on the primary, those transactions are written into something that we call the log cache, which is basically an in-memory section where we keep all those transactions. And then when the transaction commits or that cache is full, we go and write all those transactions into the log, right? And then from the log, they're actually physically applied into the data pages, right? And then that's how you make them visible into the tables and users can query from them. We have this component called the log pool, and what we are doing here is we keep copies of those transactions in the log pool, right, until the secondaries acknowledge back those transactions, right? And this is so that if they don't acknowledge back the transactions, we'll try to resend them to them. And then we have something called the log capture process. Basically, for every database that you have in the availability group, we have a separate thread that will read the log for that database, and it will send it over the network to the next secondary. And then on the secondary, you have a process called log receive. It receives the log from the network, and then it goes and writes it into the log cache, right? It's very symmetric to what happens on the primary. And then once this is written into the log cache, this is actually physically written into the log. And then we have a separate process that is asynchronous that is reading from the log and is redoing these transactions on the secondary. Right? And until this guy goes and reduces operations on the secondary is when the transactions becomes available on the primary, on the read of secondary, sorry. So the only important thing here to consider is this is an asynchronous process, right? So there are like 3 steps. They happen asynchronously, and that's why there may be latency between each of those steps, right? This is why you can't automatically see every transaction on the secondary. Now, a common question is, if I execute these read words on the secondary, what is going to be the impact in that secondary, right? In the end, remember that what we want is that secondary to be available for failover, right, in most cases. So what is the impact? Well, the impact is that read workload is going to take resources. It's going to take I/O, and it's going to take CPU from that machine. So because of this, the redo thread that is continually redoing the log into the physical pages can fall behind, right? I mean, it's competing for resources. So this can be a problem if the secondary, for example, is configured for automatic failover, right? Why? Well, because if the failover happens, that secondary may have a large queue of log that it still needs to redo, right? So that's additional time that will need to happen for that secondary to become available for connections, right? So that is going to impact the RTO, right, of your applications, how long before they can connect and continue working. So is the problem clear, right? So there are a couple of things that you can do. One of the things is you can actually use resource governor to control the amount of resources used by that warlord in the secondary, right? Or the other thing is, if you can, just avoid running those warlords on the automatic failover secondary and run them in another secondary, okay? What is this? Okay. Okay, so common question again, a lot of people ask, how do you avoid contention, how do you avoid blocking between this redo process that is trying to redo the lock and the read warlords, right? They may be trying to get the same locks. How do you ensure that they don't block each other? So we are doing 3 things for this. The first thing is we execute the read warlords in a snapshot isolation mode. Right? This means optimistic concurrency. We have a separate copy of all of those records so that they don't have to go and access the same record locks. We ignore locking hints. So if you have any hints to try to set up some locks, we're going to ignore them because we don't want to impact the redo thread. And finally, in the case that we detect a deadlock, we will never choose the redo thread as a deadlock victim. We'll always choose the read warlord. Right? This is to protect the redo thread and make sure that we don't impact failover time. Something to consider is DDL. When you try to redo the DDL on the secondary, that can still run into blocking issues with the read warlord. And the reason is that the read warlord needs a type of lock called schema stability. And that means when I retrieve some records from the database, I want to make sure that the schema of that database doesn't change, right? So if I select, let's say, a couple of records from a table and they have 3 columns, I want to make sure that those records don't change while I'm executing a transaction. So they need to acquire that schema stability lock. The problem is that DDL also needs to acquire that a schema update lock, and then they may end up blocking each other. The good news is that DDL is very infrequent, right? Normally, you do this, maybe once or twice every week. You don't need to change the schema very frequently. So if possible, try to run it when there is low activity in the system, during night, early in the morning, if you're a morning person. If you can't, something that we give you is an X event. This X event is called lock redo blocked. So if we detect that the redo thread is being blocked by a DDL statement, we'll generate this X event, and then you can capture that X event, and you can read, for example, what is the query that is blocking the redo thread, and you can automatically kill it if you want to. Right? So you have the option to do that. Any questions? Okay, so another question that I frequently get is, how do we optimize queries on the secondaries, right? So remember that by default, what we use in SQL is, for query optimization is something called statistics. So statistics give me information about the tables that I have in the system. What is the selectivity of the columns, how many different values they have, which columns should I use to read from, and to locate values as quickly as possible. Now, the problem here is statistics. So the statistics on the readable secondary, by default, are created from the statistics on the primary, right? So you run some warlords on the primary, those generate the statistics, and those statistics are sent as part of the log to the secondaries, and then we redo those statistics, right? Now, the problem here is that the warlords that run in the readable secondaries may be different from the ones in the primary, right? On the primary, you may be running some updates and inserts, and you'll be touching certain columns. But for the readable secondaries, for the read warlords, you may be able to, you may want to query other columns, right? The columns may be different, for example. So we need to somehow create statistics for the columns that the read warlords are using on the secondaries. So how do we do this? Well, given that the databases in the readable secondary are readable, right? We cannot go and update them because they are readable. What we are doing is we actually generate the statistics on the readable secondary based on the read warlords, but we store them in TempDB on the SQL Server instance, right, for the replica. So we actually store those statistics in TempDB. You can identify them. So if you go into sys.stats, as usual, you can look up for the isTemporary column. If isTemporary equals to true, then this is an automatically created statistic from the readable secondary. Now, what we do in the readable secondary is we look at the statistics that we have from the primary, and the statistics that we automatically create on the secondary, and we use the most recent ones, right? Because those are the ones that are reflecting the state of those tables more recently. And then, as usual, if you're worried about space, for example, in TempDB, you can either remove these statistics manually with drop statistics, or we remove them every time that a failover or a restart happens as well. Okay, questions? Yes? Yeah.
Like primary and my synchronized secondary here, and over here I've got a pair of asynchronous secondaries.
Yeah.
I've lost my data center.
Yeah.
What's the process to make one a master? And then once that's a master, how do you start throwing away records that the master didn't receive on the other nodes when they come back up?
Records that the master didn't receive. Okay, so you're saying you have a disaster recovery side, different side.
I've got synchronized between a pair over here.
Okay.
And I've got an
Asynchronous, okay.
two over here.
Okay.
This is gone, so this becomes master.
Right.
Because these were asynchronous, the one that's actually now secondary might have been ahead.
Right.
How does it yield to this being master and become synchronous to it?
Ah, that's a, right,
When this one comes back up,
right,
because maybe this had got to, say, 1,000,
Yeah.
and this had got to 990,
right.
how does this one know that 991 for 1,000 have to be thrown away because there's a new 991 for 1,000?
Great question. You get me in trouble here. Okay, so the question is, I have two data sites. My main data site, I have a synchronous secondary in that data site. In the disaster recovery site, I have two secondaries, are asynchronous secondaries. And then let's say that a disaster happens and I fail over to one of the asynchronous secondaries. What will happen with the other ones, right? Like maybe, for example, the other asynchronous secondary may have been, it may have had more log than the other one, right? So what's going to happen with that log? The good and bad news is that log is going to be lost. And this is because we don't guarantee, we don't guarantee that we're going to fail over to the secondary that has the most recent version of the log, right? Unless you're using synchronous secondaries within the same data center, because all of them are going to be synchronous and it's the same thing. But across asynchronous secondaries, we don't guarantee that. So in that case, whatever you fail over manually, so you have to do a manual failover process for asynchronous secondaries, because we don't support automatic failover for asynchronous secondaries, given that we don't want to just allow data loss without you, making sure that you're not losing data. So you have to do a manual failover. You have to decide which of the two asynchronous secondaries you're going to manually fail over to, and then that becomes the primary, and the rest of the secondaries will basically have to undo any transactions that are, ahead of what that secondary node, the new primary knows, and then they will have to reconnect to that one and automatically start catching up. I mean, the process is automatic, but yeah, secondaries that have more log than the new primary will lose it. So in general, what you have to do is we provide you a lot of information with DMVs about what are the last transaction, we call them transaction LSN, log sequence numbers, that have been redone in those secondaries. So you can look at which of the secondaries are the ones that have the most updated information, and you can choose to manually fail over to that one. Does that answer your question? Okay, thank you. Okay, let's move into backups. Let's see how much time we have. 20 minutes, still have plenty of time. Okay, so backups. How did it work before SQL Server 2012? So the way this works is you run it on the primary. That's the only option. You have to run it on the primary, right? And the problem is running these backups is may impact the throughput of your primary, because it's going to make use of I/O, a little bit of CPU, but mainly I/O. We really trash I/O when we take backups. We try to do it as fast as possible. So if you're running workloads, those workloads are going to be impacted by the backups. In case that you have database mirroring, you will be running these backups from the primary, and then, so assume that the primary fails for some reason. Those backups are going to fail, right? So somehow now you need to move those backups into the new primary, right? So what a lot of people do is that they have backup jobs running on the primary and on the mirror, and they have a condition at the top that says only run if it's the primary. You can say if server role equals to primary, then run there. Okay, so yeah, the problems are you cannot run it on the secondaries. You cannot use the secondaries for that. And also, if failovers happen, the jobs are going to be impacted. So how does it work now? Well, now you can run the backups on the primary or on any secondary in the system. So you can have backups on the primary or secondaries. You don't need to do any specific configuration for readable secondaries. I showed you before how you configure the secondaries as readable. So even if the secondaries are not readable, like if you didn't do that, you will still be able to create backups on the secondary. So what are the capabilities that we have in this release? We can take backups from either synchronous or asynchronous secondaries. The obvious consideration here is synchronous secondaries are going to be very, very close to the primary. Right? So it's going to have the same transactions as the primary has. So the backups are going to contain a most updated version of the transactions. We support two types of backups. We support full backups, and we support log backups. Unfortunately, we don't support differential backups. I know people get sad when they hear that. We didn't have enough time to do that. So we don't support differential backups at this point. And because of this, we only support one type of full backup. It's called full backup copy only. So just to clarify this, this is exactly the same thing as the full backup. The only difference is when you take this full backup, we don't clear the differential bitmap. The differential bitmap is basically a bitmap that stores all the transactions that have changed since the last full or differential backup. So we don't clear that. And yeah, again, this is not important if you're not using differential backups, but if you're using differential backups, then this copy-only backup will not be useful to you. Yes? Excuse me?
Is it also written to the backups table on the master database?
The backups are written to the table. I'm pretty sure they are, yeah. So yeah, if you look into the master, you'll still have the backup history there. And the final thing is we support backup automation. So now you have multiple secondaries. It may become confusing. Where do I take the backups? How do I do it? So we actually allow you to automate this backup process. And I'll show you how in the demo. This is really, really cool. I really like this. This means even if you take log backups in different secondaries, right, we are going to build a single logical log backup chain. What this means is that I can take backups in a backup in replica 1, then take the next log backup in replica 2, then replica 1, replica 2, and then you can go and restore all of those backups, and you're going to have a consistent database. That's cool, isn't it? You can actually go and use all of these databases for backups, and then restore in a single place. Okay, so how does this changes your backup strategy? How are you going to do it now with SQL Server 2012? Well, you have two options. One of the options is I run it on the secondaries, right? And then I run my full backup copy only, every week or every 3 days. And then I run my log backups every 30 minutes, 40 minutes. That's one option. That may or may not work depending on the amount of log that you're generating in the system. Right? If you're generating loss and loss and loss and loss and log, probably the restore operation for these log backups is going to take a long time, and you may not want that. So if you have a very, very high amount of log generated, you will still need to take differential backups. And for doing that, you'll need to take the full backups and the differential backups on the primary, right? But you can still take the log backups on the secondary, right? So those are the two options. Is that clear? Yes? Excuse me?
You support backup solutions that are using the VSS writer, like DTM, on the secondaries?
Yeah, so the question is, what about third-party solutions for backups? Can they work on top of this? Yes. So every third-party solution can make use. We can take the backups from the secondary. Now, whether they are already doing it as part of their management solutions. Some are doing it, some aren't. So they'll need some time probably to go and completely make use of this functionality. But they are able to do it. Backup automation. Okay, so we allow you to take backups in different places. We let you specify where you want these backups to take place. So you can say, I want to take the backups only on the primary, or only on the secondary, or preferably on the secondary, but if the secondary isn't available, take it on the primary. Or I don't care, take it anywhere it's available, right? So you can specify all these options. You can specify priorities on each of these replicas. So for example, you can say, this replica is synchronous and is close to my primary. I want to take the backups there because it's going to have a most recent version of the data. So you can specify a priority there. You can say, I never want to take backups here with 0. You can say, I always want to take backups here with 100. Right? So how do we decide then where to take the backups? Well, first we filter our replicas based on the role selection. So we filter our replicas that are not online. If for some reason SQL Server is not online, we just don't look at it. And then we look at the role preference. So do you say primary or secondary? What do you prefer? And then if you say primary, I don't care about secondaries, right? And then I look at the highest priority. So I say, well, I have 2 replicas. Highest priority is this one, then I use that one. And in case that there is a tie between the replicas, we just break the tie with the replica name. Okay? Now, here is something very, very important. We do not enforce this backup automation as part of the backup tsql command. So we allow you still to go and run the backup SQL command anywhere you want. Right? We don't enforce it. Like we don't block it, for example, because of those settings. So what we do is we have an internal, actually not internal, it's an external, because you can see it, a system function that is called backup is preferred replica. This function receives as an argument a database, and it returns whether or not the local replica is the preferred replica to take the backup for that database. Okay? So that system function tells you, am I the preferred replica for this database or not, based on the settings that you have specified. So you can use that if you already have existing jobs and you want now to make use of that preferences, you can go and use that system function into your backup jobs. Or if you go and create new backup plans with the maintenance plan wizard, right? How many people have seen the maintenance plan wizard? Okay, so if you go and create a new plan with the wizard, it will automatically contain the function, and it will contain all the logic for taking the backup only on the places that you want to. Same thing for the log shipping wizard, right? If you set up log shipping using the wizard, we're only going to take the logs on the replicas that you specify. A couple of recommendations. If possible, try to store your backups in a single place. It may get confusing if you have backups across 4 secondaries. Some people get really confused about it. And then try to use Recovery Advisor. Basically, this new feature in SQL Server 2012 allows you to simplify the restore process. I'll show you how it works. But basically, you can now easily restore to a particular point in time. So you can say, for all of these backups, I want to restore to either this backup or to 5 hours ago. And then you can go and restore to that point. Really, really nice. So let's go into the demo. I always have problems. Let's see. Okay. So let's see. Okay. Okay. So for specifying the backup preferences, you go into backup preferences, and then by default, I think it's the primary. So you can now select each of the other options. So I can say I want to take backups only on secondaries, right? And I know that this one is synchronous, so I want to take the backup there, so I'm going to give it 100. And then I say, Okay. So let's see if okay. So if I go and run my system function on the primary, it's going to tell me you are not the preferred replica. If I run it, let's say in server 3, I think this is the one that I specify, to tell me you are the preferred replica, right, for this database. By the way, I'm going to use Adventure Ref. It's just one of the 2 databases that I have in the availability group. And then if I go into the other secondary, server 5, and I try to run the same, it's going to tell me that I am not the preferred replica, right? So in your backup jobs, you can make use of that system function and say, only if I'm the preferred replica, take the backup, right? So let's actually look at how this works. So I have a database here, AdventureWorks Ref. Let me select from a table. So in the table I have, I need a space. In the table I have 11 records, okay? So let's go and take a full backup with those 11 records. So I'm going to take this from one of the secondaries. So I go into the secondary here, and then I can take the full backup. So you can see this is specifying a full backup, and then I'm storing this in a network share in server 2. So this is a network share, so every secondary can access that network share to create backups there. And then the name of the backup is going to be AdventureWorks Ref full server 3, just to be able to identify it. Here's the interesting part. I have this with copy-only thing, and this is just because we don't allow you the regular full backup, because we don't clear the differential mid-map. So let me take this. So if I take a full backup, this creates a full backup for the database. I can go into server 2. I can look into, this is a folder where I'm storing it, and you can see the full backup there, right? Created from the other secondary. Now, let me go and insert more values. So let me see what is the last value here. So 11 is the last value. Let me go and insert 12. 12. Okay, so I insert a value, and then I'm going to take another log backup from another secondary. So I could take it again from server 3, but to make it more interesting, I'm going to take it from a different secondary. Right? So I'm going to go into server 5, and I'm going to take the log backup. So you can see the difference is I'm specifying log backup. Right? It's a regular backup. Right? So I take this. This is going to be server 5. That's the name of the backup, log server 5. So I run this. Again, if I go back to server 2, now I have the other backup from this. And just to finish, I'm going to insert another value and take another backup from a different secondary. So I'll take 13 and 13, insert this one, and then let me go and take it from a different one. So I take the previous one for 5. Let me take now this one from 3, right? So it's going to be, again, a log backup. It's called server 3 back. I run this one. And now if I go back, I have my full backup plus 2 log backups taken from different secondaries, right? So let's go and restore the backups. So I'm going to go into databases and say restore database. Here I'm going to say I want to restore device because this comes from files. I'm going to say these files are, and then I'm going to go into my folder, and then I have the full plus the 2 log backups that I took. I say yes. Okay. I'm going to change the name of the database because if I don't, this is going to try to rewrite the existing database that I have. That's going to give me an error, so I'm going to say ref2. And then I'm going to say I don't need to take tail log backup. So the tail log backup basically goes and takes another backup on the primary for any data that is not available in the backups that you have. In this case, I have all the data there, so I'm not going to select that. In terms of files, again, I'm going to change the directory, because if I try the existing files, it's going to have a conflict with the files for the existing databases. So let me go and select something else. So let's go and select temp, for example. So select temp. OK, so I think everything is ready. So if I go back here, this is the interesting part that I was telling you about, Restore Advisor. So if I click in Timeline, this basically allows you to restore either the last backup taken, or you can go to a specific point in time. Right now, I only have these 2 minutes, really, so it's not very exciting. But if you have more backups, you can go back, more in history. So yeah, just basically go and click Enter. Let's see, what happened here? Store of database failed. OK. I told you. So I tried to use existing file path for existing log record. So obviously I can do that because that's being used for something else. So I'm going to go and change this to setemp, and hopefully this will work. OK, so restore successful. So we have just restored the database from full and log backups taken from different secondaries in the system. So now if I go back to this database and I run a query from here and say select everything from, let me see, what is the name of the table? TVL test. This is going to contain all the records that I inserted on the primary. Is that clear? Any questions? Yes? OK, good question. So the question is, I'm assuming you're talking about the truncation of the log on the primary. When do we truncate the log? Every time that you take a log backup from the secondary, we actually truncate the log. Right? On the other ones as well. So we truncate the log on the primary, and then that is synchronized to the secondaries. OK? Any other questions? OK. So let's go back to the slide deck. Announcement. So this is an announcement that we are giving at TechEd. And the announcement is later this year, you will be able to create secondaries in the cloud in Windows Azure. So if you have SQL Server 2012, you can create an availability group for your databases, and you can have those secondaries in the cloud. Right? So we will be able to have disaster recovery for your databases, so that in the case that your server, for example, becomes unavailable, questions, I see lots of questions already, you'll be able to fail over automatically to the secondary in the cloud. Yes? Right. So the question is, the cloud sucks because there are a lot of features that are not supported on my on-prem environment, right? It doesn't suck, come on. So they're actually, as part of the cloud, we have two offerings. We have the traditional SQL Azure offering, right, where we're still working on enabling some of these capabilities. Here I'm talking about a different offering that we released, I think, a month ago. It's called Persistent VMs in Windows Azure, right? There are a lot of talks about that in TechEd. And what this is basically VMs that survive failures, right? And you can have these VMs in Windows Azure. And now you can go into Windows Azure, and in the portal you can say, I want a SQL Server VM, and it will go and provision a SQL Server VM, right? That is the offering that we're talking about. We're actually opening the possibility to connect to those VMs from your on-prem environment, and then you'll be able to add a secondary in there. Right? And you'll be able to go and run queries into those secondaries. So if you want to start moving some of your workloads into the cloud, you can use a local copy. And also, if for some reason your primary fails, it will provide you with disaster recovery support. Really, really cool. Okay, so in summary, what have we talked about today? Well, we talked about, we want to make hardware cost-effective. We want to make use of it. We don't want to waste resources. With SQL Server 2012 AlwaysOn, you're able to do this. With these active secondaries, you can now go and run read workloads, right? You can move those from the primary into the secondaries. You have the option to do it without client changes, but if you have access to the connection string, you can use this application intent, and we will automatically route you to readable secondaries. You can also run backups on the secondaries, right? Full backups and log backups, not differential yet. And we provide you with automatic support for where to take the backups, right? And we have Windows Azure support coming for your secondaries this year. Additional resources, the AlwaysOn Resource Center is the best place to go. You go there, and you have lots and lots of information about AlwaysOn. There is a team blog. We write there every month, and we have new ideas and new things, new capabilities. We write about them there. We have white papers, so if you want to go and learn more information about AlwaysOn, and you want to read actually, technical case studies of how people are doing this with AlwaysOn, you can go into that address. If you have any questions, if I can help you with anything, that's my job. I really enjoy helping people architect solutions, high availability, disaster recovery, all of that. So my email is there. There is also a forum. You can go and ask questions there. And I think that's it. Any questions? Yes?
System databases.
Yeah.
They are not supported, right?
Yeah. So
Do you have any plan, roadmap to want to do that, or you just leave it for failover?
So the question is, today we don't support failover of system databases. Are we going to support it later? Yeah, unfortunately we don't support it yet. We have it in the roadmap. It may happen the next release, but we are looking because we're prioritizing other features as well. At least there is a workaround right now. You can actually have different, for the objects that live in the system databases, like agent jobs and link servers and all those things, you can actually manually move them. It's not the greatest solution, but at least there is a workaround. So we're looking in the roadmap, and maybe next release or the release after. Any other questions? Yes? Yes? If you have a synchronous secondary, yeah? The primary is still able to continue working. The question was, what happens if the synchronous secondary fails? The primary is still able to continue. If that synchronous secondary was configured for automatic failover, the only thing is that the primary is going to run unprotected. Right? You need to go and select another one. Any other questions? Well, thank you, everybody. I appreciate it. I'm going to be tomorrow at the SQL Server booth. So if you have any questions, please just pass by. We have some demos there as well. And thank you for coming here today. Thank you.